There are three main types of analysis when dealing with the time complexity of an algorithm: the worst case analysis, the best case analysis, and the average case analysis. Now, talking about the best case running time of an algorithm is bogus. Okay, we usually don't care about it. We mostly deal with the worst case analysis. So for this course, that is what we'll stick to when talking about running times of an algorithm. The average case analysis is usually complex, so we will not really talk about it in this course. Sometimes average case analysis requires understanding and using some statistical methods also. To be able to analyze an algorithm, we need to make a few assumptions on how the operations are performed on the data. This is called the RAM model of computation. And we assume that we have infinite memory. That is, we don't really worry about memory constraints when analyzing algorithms. We assume that each operation that we do, whether it is a mathematical operation or any other, it takes 1 unit of time. Then each memory access step takes 1 unit of time. That is, when we want to read the data in a slot, that will take 1 step. Or if we move the data to another slot, that can be treated as 1 step and hence would take 1 unit time. We also do not care where the data is read from, whether it is being read from a real RAM or a hard disk drive or even from a network data stream. We assume that all the data is stored in the RAM, and that is where we are accessing it from, or that we are moving the data around within the RAM itself. After making these assumptions, let's start to try and analyze the time complexity of the bubble sort algorithm, which you already know now from the previous chapter.